Hello guys, welcome back to my channel Based on African Motives. Still working on revisions on engineering science and still on the question paper which was written in February 2022, working on work, power and efficiency. So if you're new to my channel, you can consider subscribing so that you won't miss any of the classes that we shall be having from Based on African Motives. Okay, so like I was saying, we're going to be focusing on work, power and efficiency, which is the question paper that we are having from February 2022. Okay, so the first part that you're given on 4.1 is to define the term work done. Okay, so define the term work done. So I'm having a quite good definition that you can actually use to define the work done. As it is defined as the product of a force and the distance which the body moves as a result of the application of the force. So that is a simpler definition actually. The product of the force. So what is important is what you're multiplying is the force and the distance. These two should be there, which is actually as a result of the application of the force. So this part is actually very important. When you are answering, you have to list this part as it is. Okay, so that's what you had there on work done. Then the other part is the following graph on 4.2. The following graph below represents the force distance graph. Okay, that's a force distance graph of a machine hoisting the load vertically up the building with a cable wounded on the drum. Okay, so that's what you had. You're given the force. Take note, it's in newtons. Okay, you've got the displacement, which is in meters. Then the first question on 4.21 is to calculate the total. Take note, it is the total work done in hoisting the load. Okay, so we know that the total work done is equivalent to the area. Okay, so this is 4.21, where we know that the total work done, is equivalent to the total area. So what is the total area in this case? Okay, so with the work done, let's cross check here. We've got two possible. You can just use the whole shape, which is a trapezium, or you can just divide into two, a rectangle and a triangle. Okay, so from a rectangle, we know that area of a rectangle is length times breadth. Okay, so we are going to have length times breadth for the rectangle plus the area of a triangle, which is half base times the perpendicular height. So it's half base times the perpendicular height, so it's just half bh. Okay, let's just substitute length times breadth. Okay, this is 100 and this is 10,000, so you're going to multiply 10,000 times 100, which is this rectangle here. So this is 1,000 from this point up to this point is 10,000. 10,000 times 100, so you're going to have 10,000 multiplied by 100 like this, plus half multiplied by the base times the height. Okay, so let's cross check here. From this point up to this point here, this is the base, which is actually 100, is the same thing, which is 100. Okay, so we're going to have 100 multiplied by the height, which is from this point up to this point. This is the height of what? Of the triangle. So which means you need the difference between these two, which is actually 14,000 minus 10,000. Okay, so it's going to be 4,000. If you subtract properly here, you're going to obtain 4,000. All right, so if this be what we have, we can actually combine this. Okay, multiply these two, we are going to obtain something like 1 million, plus combine this multiplied by a half is going to be 200,000 if I'm not mistaken there. So you just multiply properly, but you're going to obtain something like 200,000 because this will be 3 2, so it's yes. Then you combine, this is going to be 1200,000, all right, which is 6. So this is work done, which is measured in joules. Okay, so you can write this in kilojoules, which is 1, 2, 3. So it's going to be 1,200 kilojoules, or you can write this as 1, 2, 3, 4, 5, 6, which is 1.2 megajoules. Okay, so you can choose it, write like this, or leave it like this, or like this. So there are so many ways that you can write it, but that is the total work done. If you're asked to calculate the work done, the total work done is actually the area under the graph. Okay. Then on 4.22, you are now asked to calculate the power required when the end of the cable is 40 meters away. Sorry for that. So you're given that the cable is 40 meters away from the drum and the velocity is 20 meters per second. So take note, guys, previously here we have got 100 meters, but now it is 40 meters away. Okay, then the velocity is fine. We actually know that, okay, let me explain this. We actually know that power is equivalent to the force times the velocity. We know that, guys. Okay, I think we all know this part, that the power is equivalent to the force times the velocity. But this resultant force, guys, is now affected. How is it affected? If you were to cross-check, we have this force of 10,000, which is actually the reference force of 10,000. Then now we are being told that here it's no longer at that moment. It is now affected by, here it's now 40 meters away, which means if it is 40 meters away, which means let's say we've got 40. So how are we going to have this? How are we going to calculate if it is 40 meters away from the drum? All right. In a condition like this, you are going to calculate the force that is going to correspond with this 40 meters. But where are we going to have this? We must have the weight of this hoisting load, which is actually, we are talking about represent the machine hoisting vertical up with a cable. So sometimes it can be a chain. So that is why I was looking actually what are you talking about. So this is actually a cable that you're talking about. So you need to find the weight of this cable per meter so that you can multiply this by 40 meters to find the corresponding weight. Okay, so how are we going to find this? So let's start by first, we know the relationship is that the weight per meter that you want to calculate actually is equivalent to the weight that you are going to have in between. So you're going to find the difference between these two. Okay, you find the difference between the two, which is 14,000 minus 10,000, which is the weight, over the distance which was used before. So before we had a distance of 100. All right, so this is going to be divided by 100 like this. So which means this is going to give us something like, if you divide properly, it's going to be 4,000. If I'm not mistaken, you're going to subtract 4,000 over 100. Then you're going to have 40 Newton per meter. So previously, you are given that the cable is having 40 Newton per meter. But now we are given that when it is 40 meters away. So being 40 meters away, which means we are now given the displacement, which is 40 meters. So you're going to multiply this by 40 meters. So by multiplying this by 40 meters, you're actually finding the force, which is the one actually that you're going to add. It's not like the resultant. And so let's just say for the cable, then you're going to add it to this. Okay, so you're going to multiply 40 times 40, which is going to give us 1,600. So this is now the required force, which is 1,600 in newtons. So all together now, this force that we need, because remember we need to multiply this by the velocity, so the force now is going to be the force that you are given, which is 1600 plus 10,000. Remember where we are given here, at this point, this is your cable, so you're going to have the force now of 1600 and the one that we are given here of what, of 10,000. So you're now going to add the difference. Okay, so you add, which is 10,000 plus 1600. Okay, so if you add these two, you are going to obtain this is going to be 116 like this 00 newtons. So this is actually the resultant force. So you add the one that you obtained to this of 10,000. So take note, guys, you are going to add the two, so you're going to obtain which is 16,600, which is actually below this one. This one was at 14,000. Now you're at 16, which is actually maybe at this point. So because it's affected, it's no longer at 100, it is now at 40. So you have to add that one that corresponds with what, with 40. Okay, so why are we calculating this force? Remember, we said that power is equivalent to force times the velocity. So if power is first the force times the velocity, now you've got the force. The power is going to be the force of 11,600 multiplied by the velocity, okay, of which we are given that the velocity in this case is 20 meters per second. So you're going to multiply by 20. Okay, so if you multiply this by 20, you are going to obtain something like 232,000 watts. Okay, remember power is measured in what, in watts, like this. This is watts for power. Okay, so because of these three zeros, you can actually write this as 232 kilowatts. Okay, so remember 3 kilo means 1,000, so you can actually remove the 1,000 here and represent it with a kilo. Kilo means 1,000, so that's what you can actually do. Okay, then the other question on 4.23 was to calculate the total weight of the cable. Okay, so in this case, the total weight of the cable is actually just the difference, because this is the cable, so it's the difference between these two. So this is 4.23, so it's just the difference here between these two, which is 14,000 minus 10,000. So it's 14,000 minus 10,000, that is the weight. Okay, which is going to give us 4,000 newtons. But if, is that clear? Let me just try to adjust. Sorry for that, let me adjust here. I don't know what happened. Okay, so you're going to obtain 4,000 in this case. So that's how actually they ask this question. Take note, this is weight, guys. If the question was asking you to calculate the mass, that is where you're going to take this 4,000 and calculate the mass, because you know that the weight is equivalent to mg. So in this case, they just need the weight. So if it is the mass, you're going to calculate the mass now using this formula, that weight is equivalent to mg. You divide by g, which is 9.8, to the weight, that which is this one. You are going to obtain the what, the mass. But in this case, you are not asked to calculate the mass. It is weight, so you just find the difference between the two. That is why actually you're given that as a 1 mark. You're just given 1 mark there. So as you can see, guys, these are the typical questions, actually how they ask these questions. So not to miss these classes, guys, from Maison African Motives, make sure that you become part of the family Maison African Motives by subscribing, so that we move together as a family. But as you can see, that's how they ask these questions, and what we need is simply to revise much questions from past exam papers and from our textbooks as we move on as a family. So that's it, guys, till we meet again.